Okay, so what is the general principle for inclusion and exclusion? What's the general idea? Go ahead.
So you want to you have to count the cases you have no restrictions.
Right.
And you have to subtract away the cases where you have one restriction. You have to add in the cases where you have two. You have to subtract 3 restrictions at 4 and so on.
Yeah, so and the tricky thing here is understanding what the restrictions are. But the no restriction case is actually pretty easy. What is that?
It's just 7 factorial.
So 7 factorial. We just pretend there's no restrictions. How many ways can we make numbers using the numbers 1 through 7? Well, it's 7 factorial.
Yeah.
Okay, but now comes the tricky part. We got to think about what are the restrictions involved in this problem.
So you can't have any numbers that share a common factor next to each other.
You can't have numbers that share a common factor next to each other. So how are we going to represent that restriction?
Well, I think what the solution did is it said that you can have one pair of non-relatively prime integers, so like 2 and 4 next to each other, for example.
So the trick to the solution is to look at pairs that you can't have. So we can't have 2 and 4.
You also can't have 2 and 6.
Can't have 2 and 6.
Can't have 3 and 6.
Can't have 3 and 6.
You can't have 4 and 6.
Can't have 4 and 6.
And that's all of them.
Okay.
Yeah.
Common divisor here is
2.
Here is
2.
Here is
3.
Here is
2.
Yeah, so these are our ones that have common divisors. We can't have those pairs. So if we're going to subtract away the one restriction case, so I'm gonna so we start with 7 factorial. Now we're going to subtract away the restrictions. So let's look. So we got 4 cases with restrictions. So how many are there that have? How many arrangements are there that have the 2 and the 4 next to each other?
Well, you can have 6 arrangements. You have to place the 2 and the 4 somewhere.
Well, they have to be next to each other, though.
You have to place the pair 2 and the 4, and you have some amount of slots to do that.
Okay. And then how many numbers do I have left after that?
And then you have 5 numbers.
Okay, so I have 6 places to put down the pair.
And you have
5 left after that. So how many is that total?
It's 6 factorial.
Yep. And then there's one other case here with the 2 and the 4. What is it?
Well, you have to divide by 2 because you can flip the 4 and the 2.
Well,
Not.
you multiply.
You
by
multiply by 2 in this case because
They're not the same case.
yeah, they're not the same. They're different.
And they're counted kind of.
We count it as if it was just one thing, the pair 2 and 4. But the pair 2 and 4 and the pair 4 2.
That's
Work.
different.
So for each one of these cases, I've got 2 times 6 factorial. And how many cases do I have?
You have 4 cases.
4. So I have to subtract away 4 times 2 times 6 factorial. You shook your shoulders there. Why?
Because, well, you can just make this 8 times 6 factorial.
Okay, I can make it 8 times 6 factorial. That's fine. Does that bother you at all? 7 factorial minus 8 times 6 factorial?
Not really.
Does it bother you?
Nope.
What's strange about this number so far?
Well, we've subtracted more than we started with.
We have a negative number now. 8's bigger than 7, right?
Yeah.
7 factorial is 7 times 6 factorial. So this is actually minus 6 factorial. So we have a negative number here, but we're about to add something back in, our 2 restrictions.
2 restrictions, 2 pairs that are the same.
Yeah, so we got to count the pairs now. Okay, so let's go on to that.
Okay.